we can have a finite series, which means what? It's limited. It has an ending point. So what other type are we going to have? Infinite. I don't know, because English sucks. So finite series, obviously they have an end point. These ones are going to go on forever and be infinite. Okay, so if we're trying to find the sum of a series, we're going to be able to do that for this. Do you think we can find the sum of an infinite series? No. The answer is occasionally, but for our purposes today, we're not going to. We can find, we'll talk more about that later, but today, if it's an infinite series, you're going to be able to come up with a rule, not the sum, but for a finite series, obviously you can work out the sum, and we've got some, I know, we have some ways of doing that. There's a formula that we use. So what I'm going to do is show you some new notation. So you know how we like to use Greek letters in maths? We're going to do that. I'm going to make this a little bit, oops. Yeah, okay, good. So, okay, right, this means the sum of. Okay, so if I'm going to say the sum of something, so if what I'm going to do is ask you, can you grab your pen and paper for me and write down the rule for this? Okay, here is my set of numbers. This is clearly a finite series. I would like you to write down the rule for me. Then I'm going to show you some new notation for it. Good, yep. Okay, I just heard people say 5n plus 1. That's exactly right. It's going up by 5, right? So that's going to be the number in front of n. And to get to 6, you have to add 1. So that's how you do it. Or you can use our rule. So u of n is the first term plus the difference n minus 1. So you can always use this to get your rule. Or you can just say, right, there's 5 between it, which means this is 5. When n is 1, I need to add 1 to get to 6. You can do it either way. I don't mind. Now, in terms of notation, I'm going to write the sum of this series. How many terms are in this series? 5. What? 1, 2, 3, 4, 5. So I'm going to put 5 on the top of sigma. Okay. So there are 5 things. Oh, it's so annoying. Why does it do that? Stop disappearing. Okay. And down the bottom, I need to tell you which number. Oh, sorry. I shouldn't have used n, should I? What letter should I be using? Nope. R. So sometimes you can use N, sometimes you can use R. They are interchangeable, but the book is largely using R, so I'm going to try and stick to that, even though last year we used N. So down the bottom, what I need to do is tell you where to start. Usually it will be 1, but not always. All right, we'll do an example where it's not 1. So what this is asking for is the sum of this series with 5 terms starting at the first term. Make sense? Where R is going to be 1. So then all I do is add them all. Well, first of all, I mean, it's pretty easy to add them all up because there's not many things in here. You can just add them all up and you get 80, right? Not a big deal. But there is a formula for when it's not so easy and you've got a lot of things to add, and we'll have a look at that in a second. All right, so I'm going to give you another sequence or another series, and I'd like you to write it in this form for me. All right, so here is my sequence. Okay, please use this notation. I have temporarily forgotten what the name of this notation is. Let me look it up. Sigma notation. There we go. That's easy. Sigma notation. All right. So you're going to need to have a rule. Yes, you're going to start from 1. Right, what number belongs on the top? 7, because there are 7 terms. I'm going to say that R is 1. What's my rule? Good. 7 and, oh, sorry, 7 R. I'm so bad at this. R. I'm going to be a pirate. All right. Did anyone actually work it out? I mean, it doesn't matter if you did. It's 175, but this is the notation, right? We're interested in this notation, sigma notation. All right. Now, you use the exact same type of notation if you're doing an infinite series. So if I wanted to do something and it looked like, let's say that we've got 10, 7, 4, 1, -2, and I have a ... on the end, that's showing you that it's an infinite series. So I want you to have a, well, actually, let's just do it. Okay, so what do you think goes on top?
What's going on with 42?
What's going on with what?
42 at the end.
Yeah.
Oh, I shouldn't have written 42. Yep, my bad. So that's 7, should be 46. My bad.
Different color.
It is a different color. I'm going to leave it there just to annoy you. All right. So this rule here is going to be what? -3n. Geez, why am I so bad at this? -3r plus 13. Good. All right. So this means I put infinity on the top because there aren't a number of terms that I'm dealing with. It is an infinite series. And then usually R is just going to be 1. And let's do an example in a minute where R is not 1. All right, let's do one here. Okay. What I'm going to do is give you, let's get rid of this. No. Why are you opening that? No, this is, you're just writing it like this. Okay, I'm just going to. Not for our purposes today, no. There are some circumstances where it's approaching something, like if it's being divided rather than multiplying, it approaches a particular value, but we're not going to worry about that right now. Okay, so I'm going to give you 8. And then I'm going to give you a rule. Okay, I would like you to give me the first term and the last term. This is a finite series, yes. Finite. It's not a finite series, finite series. Please give me the first term and the last term. Is it going to help you if I zoom? Well, that's too big. Sorry? So it is problematic. So what you, I'm going to give you the answers in a second. I just want you to have a think about what this is going to be for now. All right. Who can tell me the first term? -6. How did you get that? What? Yeah, you just put a 2 in, right? So it's 3 squared minus 15, which is -6. Okay, what about the last term? 3 to the power of what? 9. Why are we saying 9? Yeah, I get what you're saying, but it's not. It's actually 8. I get your logic, but you actually need to say no, the 8th term. It doesn't matter if it's not, this is not saying 8 terms, this is saying the 8th term. Okay, this is the place you stop. So this tells you where to start, this tells you where to stop. That might be a more helpful way to think about it. Say it again. I'm not sure what you're asking.
Term should be the second term.
But it's the first term you're allowed to use. I hear what you're saying. But because you have to start at 2, we're only adding terms 2 to 8. Right? Because we have a limitation. We're not allowed to use term 1. The first allowable term. How about that? Yeah, no, maybe the language is slightly confusing, which is 6, 5, 4, 6. I know what you're saying, but yeah, it's a language issue, I think. Oh my goodness. Okay, I'm gonna now give you the formulas of working out the sum of a series, and we'll practice doing some of that. Okay, so the sum of a series is, here's the more complicated one, n over 2. The sum, so S is the sum. Okay, so this is all the information put into that. There is a simpler version, but to use the simpler version, you need an extra piece of information, so you can't always use it. All right, this one always works, but the simpler version will only work if you also have L. And I'll talk about that in a second.
Why is it 2A? How does that?
Okay, so there is a proof in the book. So if you turn,
What's n minus 1? The first one.
what do you mean what's n minus? This is the normal way that we, well, the first term, right? This is the normal way that we do.
Oh, that's the formula.
Yes, this is the formula for the sum. All right, so when we're looking at this, there is a proof on page 125 that if proofs are going to help you understand why this works, that's what I would like you to have a look at.